this problem here is, of all the things that we're going to do this year, one of the easiest problems that almost everybody misses all the time every year, and I have no idea why. I'm sure it's something about the way I describe it or the way I explain it, but I'm going to try my best to make sense of this to you guys. It's really, really simple. Okay, how far left does this thing go?
2.
What type of 2?
Negative.
Negative 2. So right here, this is the leftmost boundary of this graph, right? And how far right does it go?
3.
Positive 3, right? That's the rightmost boundary of the graph. All right, can we all see that? Oops, trying to grab the line there. Can we all see that that's where the graph lives horizontally, right? What I just got done telling you about domain is domain's all about the input, the x-coordinate, right? So looking at the x-coordinates of all the points on this graph, they're starting at negative 2, right? Going all the way up to positive 3. We have an open circle, closed circle. We'll worry about that in a minute, all right? But the leftmost and the rightmost boundaries are negative 2 and positive 3. So if I'm writing out domain, it's going to start off looking like this. Domain is the set of all x values such that, that's how domain always starts off. Okay? All we have to figure out every single time in these problems is what goes right here. All right? Everything else about domain always looks the same. Every single domain answer is going to look exactly like that. The only difference is going to be what's right here. That's the actual domain of the problem. All right? So I can see that the x-coordinates of every point on this graph are between negative 2 and 3. And the way we show between in algebra or in math in general is with a compound inequality. Smallest number less than x less than biggest number. And again, these two numbers were found just by looking, obviously there's negative 2, there's positive 3. Those where those two numbers came from. So when you get a problem like this where it's already graphed for you, it says find domain and range of this given graph, find me the leftmost number, find me the rightmost number. That's how you write domain out. The one other thing you have to consider is, do we need any equal signs? Right? Small number less than x less than big number. Equal signs happen because there's a closed circle. So there's a closed circle at positive 3, I'm going to put an equal sign. There's an open circle at negative 2. There's no closed circles at negative 2, are there? So we don't put the equal sign. That's all the domain is. It doesn't matter even what the graph looks like. Find me the leftmost point, find me the rightmost point. From there to there is the domain. Looking at the range. The bottom of the graph is right here. The top of the graph is right here. How far down does it go?
0.
0. How far up does it go?
4.
4, right? So the bottom is 0, the top is 4. And this is the function f, right? F of x. All right? So range equals the set of all f of x such that every range problem is going to range answer is going to look like this. The answer goes right here. And to find the answer, we simply say where f of x lives. It starts at 0. It ends at 4. And then again, we have to ask ourselves about the equals to. Okay, I think this is the part that tends to escape people. Maybe things seem a little weird and we don't like it very much, but I'm going to try and make some sense of this to you. All right, it has to do with the hollow circle or the open circle. The one that looks like this, as opposed to that. All right, here's some criteria. Ready? Listen closely. If you see a hollow circle, then there's a hollow circle. If you don't see a hollow circle, then there isn't a hollow circle. If there's both a hollow circle and a shaded in circle in the same spot, the shaded in circle wins. So let's investigate that. All I care about is right here at the bottom and right here at the top. Does anybody see a hollow circle right there? Then there isn't one. Equals. Do I see a filled in circle there? So equals. Okay? Notice there's a hollow circle here, right? There's a point right here that officially is a closed in circle. If there's a hollow circle and a filled in circle at the same place, the filled in circle wins. So the fact, it doesn't matter, there's a hollow circle here between 0 and 4. There's a closed in circle at 3 right there, which deals with that. So the equals to, all you really focus on is the endpoints. If you see a closed in circle or no circle at all at an endpoint, you're going to put the equals to. Again, it does not matter what that graph looks like. Let me give you one more quick example of this same idea, and I'll make it much more challenging. Here's my x-axis, here's my y-axis, and let's just say I'm going to put an open circle right here, let's put a closed circle right about there, and let's put a, that's probably good there. And let's just say the graph does something like this. There you go. There's our graph.
I thought it was in math, not art.
That's kind of artistic though, isn't it? It's kind of like a creature of some sort. There's this mouth and sharp teeth. Anyway, again, I don't care what the graph looks like. Focus on the boundaries of this graph. So if you take a look, I'm going to draw a box around this thing. There's where the graph lives, right?
Mm-hmm.
That's the farthest left, this is the farthest right, that's the farthest up, that's the farthest down. -1 is the farthest left. 1, 2, 3, 4, 5 is the farthest right. So if I'm going to write domain of this thing, the domain equals the set of all x values such that -1 is less than x is less than 5. Start off there. Open circle, no closed circles at all, -1, so just less than, closed circle at 5 equals 2. Looking at the range, the bottom is -1, the top is 1, 2, 3, 4. So the range is the set of all f of x such that -1 is less than f of x is less than 4. Start there. No circle is a closed circle. A closed circle is a closed circle. Equals equals. There's your answer. Much more complicated looking problem, but it's the same criteria. How far left, how far right, how far down, how far up. That's what they're asking for. Give me some compound inequalities. Less than every single time. Small number, less than letter, less than big number. Equals to if there's a filled in circle. That's how you do it.